Today we're going to start a series of calculus videos. This is what you would typically see at the beginning of an introductory calc course, mostly limits and things. This first problem is on composite functions. So they're saying let f of x equal cosine x and g of x equal square root of 1 minus 2x. Find the formula for the following functions. So they want to know g of f of x and f of g of x. And remember this notation, I find it a bit confusing. I actually prefer to write g of f of x, because that kind of shows that f of x is the inner function. So you're putting x into the f function and then taking what comes out, putting it into the g function. And the second one you can write as f of g. Actually, we want to write the other way. So f of g of x. Alright, so how do we actually do that? Well, we basically write the g function, and then when we get to an x, we instead write what the f function actually equals in its place. So in this case, the g function is square root 1 minus 2, and now instead of writing x, we write f of x, which is actually cosine x. Cosine x, and that is the g of f of x. Now for the second one, they want us to do f of g of x. We do the exact opposite. We start writing the f function, which is cosine of x. But instead of writing x, we're going to write g of x, which is 1 minus 2x square root. So 1 minus 2x under square root. And that's it for the composite functions. Now in the third part, they want us to find out the function h of x is obtained by shifting f of x 1 unit to the left, shifting it 1 unit to the left, and stretching it in the horizontal direction by a factor of 2. So first of all, what is f of x? F of x is cosine x. So what does that look like? Well, y equals cosine x, if you recall, is this basic function that starts at 1 and goes down to negative 1. And if you remember the unit circle, at 0 the cosine is 1. And then at pi over 2 the cosine is 0. This is pi over 2. And at pi the cosine is negative 1, which is down here. And at 3 pi over 2 the cosine is 0 again. And then at 2 pi the cosine is 1 again. So we're actually going to see it take this curve, if I can draw this. And that is the first period of the cosine function. Notice the period is 2 pi. That's the standard period for cosine function. It's also standard period for the sine function as well. But this isn't the most general form of the cosine function. The most general form would be to say that y equals a cosine bx minus c plus d, where each of these variables does something to the physical graph. A is the amplitude, so that gives it a vertical stretch, or it can compress it vertically. B is the frequency, so that can either compress it horizontally or expand it, stretch it horizontally. C is the horizontal shift, that moves it to the left or the right, and D is the vertical shift, that moves it up or down. So let's notice in this problem the amplitude is not different than the standard amplitude of the cosine function, right? It's still going from negative 1 to 1, so the amplitude is still 1. So A equals 1. That's the same as it would normally be. And there's no vertical shift, so D equals 0. So those don't really enter into this problem. What we do have to take account of is the fact that it's going 1 unit to the left. So there's going to be a C value, and we have to find out what that is. And it's going to be stretched in the horizontal direction, so there's going to be a B value. We need to know what that is. And B is often called the frequency. B is the frequency. So let's do C first. I think that's the easier one. If it's moving to the left, notice that the standard form has a minus sign here. So if C is positive, that implies it's moving to the right. If C is negative, that implies it's moving to the left. But because there's a minus sign here, and we want it to move to the left, we want to set C equal to negative 1. But it's going to be minus a negative 1 in the actual final formula, so we're actually going to see bx plus 1. A lot of students just memorize that if it's a plus sign, that actually moves it to the right, which is a little different than the vertical. So in our final form, it's going to be y equals cosine of bx plus 1, which is a shift to the left. Okay? And now we need to find out what the frequency is. Now what's the relationship between the period and the frequency? We said normally the frequency is 2 pi. I'm sorry, the period is 2 pi. So period is given by this formula 2 pi over b, 2 pi over the frequency. So if the period is normally 2 pi and we want to do a horizontal stretch of a factor of 2, we want the period to be twice as big. We want it to take twice as long for it to get through one cycle like this. So we actually want the period to be 4 pi. How can we choose a value for b that will make the period 4 pi? We should pick b equals 1/2, right? Because 2 pi over 1/2 would be 4 pi. So b equals 1/2. That's the frequency. And you'll notice that as the frequency gets larger than 1, then that makes the period smaller, so you'll see more than one cycle in this picture. But now we're actually stretching it, so there's going to be only part of a cycle as you go from 0 to 2 pi. So the final answer, y equals cosine 1/2 x plus 1.